Thank you, Anders, and thank you, Inge, for coordinating this event in this crazy times in the world. I'm happy to join and then share our experience about our actual collaboration with DIKU. My name is Matias, and I'm the co-founder of Rokoko, now heading our product development and our tech development, and also having this, I guess, fantastic position where we also collaborate directly with DIKU. I do not have a fancy magic card, but maybe I should at some point. Thank you for that inspirational thing. I actually have a background from economics and philosophy, but always been very inspired by how you can create new economic systems around decentralized systems. And that was actually also what kept me motivated by co-founding Rokoko in the first place. And I have some background slides about Rokoko. And if you have any concrete questions, please let me know afterwards. But I'll try to stick to Rokoko and then the actual case of what we do with DIKU. So my title for this presentation is Faster, Better, and More Intuitive Animation Tools, which is kind of an overlap of both our interest in Rokoko and also the interest of the PhD, which I'll get back to. But first, some context. Let me know if I'm speaking too fast. I'll try to do it loud and clear so everybody can follow. But this is the team, and we are now, actually we just crossed 30 people. We are a private-owned company with investors, and most of the people are in Copenhagen, close to all the fantastic game studios we have in Copenhagen. And around, I would say 50% or more are engineers building stuff. So that's motion capture tools, both consisting of a hardware component and a software component. And then we have a couple of guys in the US, in San Francisco and in LA. And then we just actually made a small remote office in Athens with some game developers there. Yeah, long story short. So we are around 30 people in total, and this is a team picture. And I think just because I saw Thomas was a part of this panel, I would like to go kind of back in memory lane because I co-founded AllCargo together with 2 people from the film school. Long story, very, very short. Their ambition was actually to take the best from games where you can interact. It's interactive by nature, and you feel empowered as a gamer, which is fantastic. But also merge that with theater, where you kind of experience something which is true and real. It's happening right here. It's right now. You have a sense of authenticity. You can, of course, also have that in games, but it's really present and it's really emotional. And also combining it with the last component, which was kind of animated movies, where you can kind of create these fantastic fairy tales and kind of stories with princesses and frogs and a lot of other stuff. And I don't know whether or not there's sound, but this is just a small look into this project. Can you hear something now? Is the sound on? Okay, that's fine. Then I will just speak. This is the recording from the film school, where you can actually see that we were utilizing an optical motion capture system from OptiTrack, hacking a face tracking solution for actually getting the actor's facial mimic on top of the digital characters. So a crowd of kids could interact with the actors, which live performed the show in real time as a new entertainment medium. And I can just let you see some of the last parts here. Perfect. Now I can actually hear something as well. So what you see here is also, of course, I guess you understand the premise. The audience here cannot see the actors. The actors are controlling like digital puppeteering or the animated characters on the scene with the means of motion capture. So that was actually the driver for doing a lot of the stuff we do today. So that's the reason why I brought this. So it's not only for the sake of Thomas, but also for the sake of understanding what we're trying to achieve. Yes, and this is just the happy, not ending, but we'll just see the last part here, where you can actually see how you can give a kind of action and you can bring things to life in new, novel ways. And again, I also have a few slides, but basically just to encapsulate what we were trying to do both back then and also now. We're really intrigued by what you can do with new kind of sensor inputs, new kind of capture technologies with kind of this OptiTrack system, but also new IMU sensors, like the ones you have in your phones and smart devices today. But also we saw, which is also still kind of in development, all of these now new interfaces to consume experiences. So not only do we have the flat screen in front of you in the movies or in on a TV, but we're also starting to have glasses and VR devices. So it's actually opening up for a whole new world to create content and consume content and distribute content, which is very interesting. And that can then be driven by new mobile CPU and DPU. So again, the mobile have really led to a lot of, I guess, communication things, but also for gaming and entertainment purposes, which is very interesting. And then last but not least, what we're also very keen on getting to know as good as we can is the game engines, which is basically a broad 3D platform for creating applications, particularly games, but you can do a lot of other stuff with them as well. So this is kind of the tools which we're trying to master in Rokoko, the company I come from. And we are particularly trying to develop new sensor inputs for creating content. So the very short vision can say we're trying to power digital humans. And we're trying to do that by actually facilitating and making a lot of creative tools that everybody can access, regardless of budget and technical expertise, to make character animation and motion capture very easy. So it's kind of a democratization project like Unity. We're very much inspired by them, but also saw the pain points we experienced back at the film school with the big OptiTrack volume, where you kind of have to have the film school budget, you have to have some public investment, you need a dedicated studios where you kind of have these cameras, which all have to see a couple of markers, and then you can do triangulations, you cannot have occlusions, you cannot have direct sunlight. It's very, very hard to set up, it's hard to operate, it's hard to maintain, and it's very expensive. So we really want to lower the threshold and the bar to starting to work with motion capture. I'll come back to why, but it's really a strong and powerful creative medium. So that was kind of the driver back then, and it still is. And today we're mainly focusing on not creating the games or the characters, but actually the tools for creating the character animation. Yes, and the case which I'm going to talk about today is then having a lot of similarities to that vision is also how can we then apply machine learning research to also lower the threshold for doing character animation in the creative industries. So we saw the motion capture is a fantastic tool, but it's super expensive. And we really want to make it super easy to use, affordable. So let's say Thomas's students on DIKU, they could actually use this for creating a lot of animation data for their content. I'll get back to the actual content of the PhD student, but just so you have an idea about the background and the challenge we are facing, both in the collaboration with DIKU, but also in Rokoko with our tools. No, sorry, I had the slide first. It's also our motivation for actually doing the collaboration with DIKU can be summed up in I think, 3 focus areas, which we could elaborate later on in the discussion if you are eager to do so. The first one is we really want to learn from the newest research out there, and this is a fantastic option to do so. We also, secondly, want to share some risk. When you are a company, you also have limited resources. And you really are forced also by investors and the board to take as little risk as possible. So in that regard, it's fantastic that we have these public funding and collaboration opportunities in Denmark where we can actually co-fund, for instance, an industrial PhD, which we did here, together with DIKU, the Innovation Fund, and us. So it's really to share some risk about something which, of course, fingers crossed, everything will work out to be a fantastic final product, which we can actually commercialize. But there is, of course, a chance that it will not happen in the quality or in the time we have available. And then the last one, the third, is actually to see some of the fantastic research being done globally, also on some of the conferences affairs where you actually have the chance to try to apply some of that. At least what we see from the industry side is there's a lot of fantastic research being done, but the research kind of realm or domain have a kind of a economy of itself. You want to be credited in fancy journals, you want to do a lot of other stuff, but there's kind of a lot of research, corpus of research, which are never actually applied and being kind of formed in a way where people can actually start to use it in an affordable manner. And so we saw a lot of potential there to also do so within utilizing a lot of data, which we had available. So some content about the problem we're facing, which is basically the same in the PhD and in our daily life. Very, very briefly, how you do character animation normally. Either you do keyframe animation, so basically like old school where you move limbs around and then you interpolate between 2 keys and then you get animation. It's a fantastic art, People are mastering it, especially in Viborg, in the animation school there. They're very good at this, but it takes a lot of time and it's very expensive to buy the right software. And it's really, yeah, it's a long, cumbersome process. Maybe if you have a high-end budget, you can do 5 seconds of animation per day or something like that. Whereas with motion capture, that is the second option. Normally the golden standard have been optical motion capture like we used on the film school. You can do a lot of animation very fast. It's kind of one-to-one. I can move around and you basically just capture all your realistic movements in real time. So you can really produce a lot, but it's very costful to establish, to set up and to maintain. And there's also a lot of cleanup and there's a lot of kind of side cost which come with that solution. So that is basically how people are doing advanced character animation today. And this is what we tried to change by making easier and more accessible animation tools. So we do this by having a couple of products. This is not kind of a sales pitch, so I'll do it super brief. We have a suit where you do body tracking. So you can do, you can animate your body movements. Then also yesterday, we just actually start to share information about the gloves. The purpose is basically the same, but it's a pair of gloves where we have these IMU sensors in each sensor in each finger, sorry, and one on the other arm. I can take the arm and then I basically start to capture my finger movements in real time, so I can apply the finger animation and the hand animation to my 3D character in space. We of course also hope that there will be tons of other applications for this, for instance in VR, AI, where you want to live interact with the world around you. The second kind of product we have is Rokoko Studio. That's our software where you visualize and record all the movement. You forward it to a third-party application. Now it's fairly simple, but we really want to leverage that so people can kind of cloud collaborate with all the animation data in real time. And the third one is our motion library, which is basically a marketplace where publishers producing very high-end motion capture assets can then share and distribute and sell the animation assets. And it's especially valuable for, again, schools and small indie game studios who do not afford either a motion capture system or to hire actors. So let's say that you want to do some stunt moves, you want to do a backflip or something else, then you can search for backflip in this motion library directly in your game engine, such as Unity. And then you can find it, pre-visualize it on your character, and then you can buy it if you want for $3. So that's really costful, and a lot of people are using this for getting animation for secondary characters or for doing previous. So in the pre-production phases, you can really block out something a lot of fast. So it's basically like you have a, I don't know, a photo stock library. It's all centered around the same idea as we had before, make it easier and more accessible to create character animation. Especially the motion library is very relevant for the PhD. So the value of motion capture in general is, and of course this is our take, that we think you can do things way faster, way cheaper, and you can actually also make more engaging content by having a proper animated character in your stories. You can tell more emotional, more appealing stories, and you can basically have a more depth and more complex narrative in all your entertainment, which is very interesting. And the way that people have been doing this so far, this is just a small clip which we normally show. This is the high end. This is the Sony studio, which is doing God of War. So this is also one of the publishers on our motion library. And he's a fantastic stuntman, and he's performing these animations, which you see in the Creaser's character in God of War, which is a fantastic piece of work, but also really, really high end. So what we're trying to do here is saying, okay, you can go into the motion library and you can actually buy Eric's animation assets for $3. So if you want some of his cool sword fighting animations, whatsoever, then you can actually go in and buy them, and you can get access to this, and then you can learn based on these experiences. And normally they have a huge, like you saw in this small animation or in this small video, they have a huge volume, which is very expensive gear. So we're trying to do that intuitive to people. And normally when you have a TV setup, you also have something like this. Of course, this is a bit a caricature. But you have a lot of gear and it's very static one place. So we're basically trying, and this is of course again a marketing picture, but I hope you get the point, to try to make a mobile and an accessible piece of hardware embedded in a full textile suit, so you can actually go on site, you can go outside, where you can actually perform animations where you want for an affordable price. And this is a picture of our smart suit, which is the main product we have developed and we sell today. Good. And this is again This is just to give you an idea about the range of creators using our tool today. So there's a lot of commercials and TV ads where they utilize this. This is again an example where you can actually use it on site for a TV commercial. And this is a one-man army creating kind of this whole mass experience. And again, a more artistic style, 2D style, where you can also use motion capture. This is for previous purposes. You can also see more cases on our website if you're curious. This is for music videos, for artistic stuff, for playing around with storyboards in 3D. Normally, when you work in kind of a storyboard pre-production phase, you don't do 3D stuff because it's too expensive in terms of timing and money. But with these kind of tools, you can actually start to do it very fast. And this is also for gameplays, some other stuff. But this is just to. We have a variety of customers around the globe. I think we have customers in 75 countries. And this is just to show you how a big volume looks and how these animation assets, which we are redistributing on the motion library, they're being produced. So here you see a big volume with, I think it's Vicon motion capture cameras, where one camera is more expensive than our entire suite. And then you can see that one person searched for an animation asset within Unity, applied to the custom characters to see whether or not it's actually appealing to their use case. I think that's happening now. And then you can actually see, wow, that looks good. I can preview it in a 3D scene, and then I can actually acquire it and download it directly to my work, and then I can visualize it like here. So it's really trying to do things faster and easier. Yes, and that brings me to the collaboration with DIKU. We have known Kenny, one of the researchers at DIKU, for some time and had a lot of research collaboration with him, and he's great. And we had an existing very great engineer. We found a common interest, and we thought, okay, we have thousands of animations in our motion library. What can we actually do with all of these data to help to achieve the same goal, but from a novel perspective? So with machine learning, we thought that we can basically solve some of the same issues, but from a different angle. So we applied for an industrial PhD, and we got it, which was fantastic. Actually, we only applied once, which is fantastic. And the goals in the PhD is threefold. So the first one is saying, okay, there's now a lot of cleanup processes, both with IMU-based motion capture system like we're doing, but also with optical systems. If we know exactly how the end result should look, like we know from the motion library data, then we should be able to train a neural network, and then we can actually do some automated cleanup processes, which can save people a lot of time. So that is kind of a low-hanging fruit. So that's one part of the project. I'll go into detail later. Then we also want to see if you basically have a person walking in the library and you have a person waving in the library, and I want an animation where you have a person waving and walking at the same time. Can I actually then take two parts of two different animation clips and bring them together? Data synthesis, which is basically, I guess, can also be a solution where you apply machine learning. That's the second topic of the PhD. And the third one is actually saying, okay, now I have a walk cycle, somebody walking generically, and now I have a drunk person. Can I extract the drunk style from one person and apply that to the walk cycle? So now I actually have a drunk walk cycle. And if I have a drunk walk cycle, can I then remove the style? So it's becoming a generic walk cycle, meaning that we can actually try to deduce and apply style to generic animation clips. So that's the three topics of the PhD. We of course hope that we can complete all of them. Maybe that's a bit naive, but let me dive into the issues. So the first issue, just to give you some context about the hardware, very brief again. Our systems are based on what you call inertial measurement units, which is the same type of sensors which you have in your phone. So we're trying to take off-the-shelf hardware component, bring it into a new context, and then redo a lot of the firmware and software. But they suffer from some issues, but the most crucial one is drift over time, because there's no absolute precision. So these sensors have a tendency to drift over time. And we're trying to see if that cleanup problem can actually be solved by this machine learning process. So that's just a background for some of the cleanup. So we're using a gyro, magnetometer, and an accelerometer, and do a lot of sensor fusion to kind of take the best from the three types of sensors, but sometimes that is not enough. So the first topic here, I just want to move this so I can see you clear, is actually the cleanup and also to synthesize data. So we have magnetic interference, which is a big issue from us. Sometimes we cannot really trust the magnetometer, but if we know exactly what could be a real truth, and then we can compare that with the input we get from the suit, then we can actually solve it. That's from the angle of our motion capture data from our suit. The angle from an optical system, like you saw from the film school, is that you have what you call occlusion, which is an issue when a camera tries to see an object, but there's another object coming in between that line of sight. So that is occlusion, and that will create a glimpse. And how you normally solve it is basically just adding more cameras to your studio. So you have less likelihood of occlusion. But for instance, if I have my hands in this pose, then the cameras will not be able to see my fingers. So you have occlusion if you have markers there. So you try basically to solve it by having more expensive cameras, more markers, more space, and it's basically just an endless loop. So we're also trying to see if we can also do cleanup based on marker occlusion issues. And then the data sensitization will basically be some of the ways that you can look at it. You're having some interpolations where you see this is to be trusted, this looks clean and good, this looks like an error, this is also clean and good. Then we sensitize between the parts we like and the parts we don't like, we skip them, as I understand it. Of course, I'm not the one carrying out the PhD. Maybe that's good. The mixing motion part is, again, as I described very early on, you have two animation clips in a database where you have one guy here, his arms have an animation part, it's going backwards and forwards. And you have another animation clip where you basically do the walking. You want to achieve a combination of both. To basically say we have thousands of animation clips, but if we kind of have endless ways that we can synthesize and mix all of these motions together, basically like you do, I don't know, music or something else, then you will have a lot of options for utilizing this database for doing something which can be maybe good enough for some background characters in the background. Maybe it will not be Gollum, or it would not be a phantom hero character because the style can end up being a bit generic, but it could be good enough to have a crowd of 10,000 people running around doing a battle or war, instead of basically just copy pasting the same animation tons of time. So that's the second focus. And the third one,
Matias, the time is running, unfortunately.
Okay,
very
sorry.
fast.
I will have two slides left. Thank you for reminding me. That's the style extraction. To say that was where I have the drunk example. Can we actually distinguish between a generic and a styled motion? And if yes, can we then know what is the style and what is the generic thing, and then apply the two to one another? As you see here, this is two ways of having a very clear style in your animation. Good. I think I have one slide. I tried to time it, Anders. Sorry for that. This is basically just an industry overview. We of course also hope, the same as Jesper just explained with this in Denmark, that now we are mainly applying our technologies to the entertainment industry, but we see a lot of the same tech can be applied in sports training, enterprise training simulation, in healthcare, VR, AI for actual inputs, digital social interaction, Facebook. It's called Facebook Reality Labs. Just had their keynote yesterday, where you see a lot of things happening there as well. So we basically hope that a lot of this tech can actually be utilized across a lot of industries. Thank you.
Thank you. Really, really interesting, Matias.